nucleophile you're dealing with and what type of solvent you're dealing with. So, if you see the polar aprotic solvents like DMSO, acetone, that's SN2, or it's also E2, the polar aprotic solvents. Know when you see SM1 and E1, that has to be polar aprotic solvents like acetonitrile and alcohol. Okay, look at the nucleophiles. Also with E1 on this chart, E1s occur at high temperature. Okay, look at the problems that we just did with the tert tert butyl. So you can look if you go under E2 under nucleophile, strong bulky bases like E2. So know that when you see that tert butyl oxide in its alcohol, more often than not that's E2. Okay. So remembering there's SN2 has inversion, R becomes S, and no E2, it's center anti or E and Z rearrangements are rare. Okay. Know that when you do SN1, you can get a racemic modification because there's a carbocation, so you get a racemate. Know this chart because you probably won't have it with you, but so you'll need to be able to distinguish reactions. All right, so let's go back to your homework problems. Hope this is helping. All right. I'll go to a question in chapter 6, 619. Given the structure of an alkene, including stereochemistry, that you would choose for the starting material for the purpose of a synthetic disparler. Okay, this is a synthesis question. She'd have to give you a starting molecule and everything for that. So I don't know if she would do that. But go through that one. Okay, here's understand. Okay, so we just talked a little bit about understand ozonolysis. Ozonolysis is a powerful organic reaction that uses ozone to cleave a carbon-carbon bond, and involves the formation of malozonide, which then rearranges to a more stable ozonide. So I'll repeat that again. The reaction mechanism generally involves the formation of malozonide, which then rearranges to the stable ozonide. Okay, so here's a reactant: 1-methyl cyclopentene, and we get a product 6-oxoheptanol. So you're going to get an aldehyde. You get a straight chain aldehyde. Ozonolysis of 1-methyl cyclopentene results in the cleavage of the carbon-carbon double bond. Because the starting material is a cyclic alkene, the ring opens to form a single linear dicarbonyl compound.
We're going to look at the cleavage of alkenes using a reaction called ozonolysis. So over here on the left, I have my generic alkene, and to that alkene, we're going to add O3 in the first step, which is ozone. And the second step, we're going to add DMS, which is dimethyl sulfide. And be careful because there are different reagents you could add in the second step. So make sure. So let me just go ahead and redraw. In red, those are the ones that formed this bond between than carbon. So oxygen is going to pull those electrons closer to it to give the oxygen a partial negative charge. Carbon's going to lose some electron density, so this carbon's going to have a partial positive those electrons, right? Because it had 2 lone pairs to start. We're going to cleave the double bond. We're going to break the double bond here. We know that our double bond, right? This is a methyl group, and over here is a hydrogen.
So here's the same question. It's amazing. Here's the same question. Let me put it back.
All right, we didn't draw it in over here. So if we're going to draw it as a straight chain, let's see how many carbons we would have aldehyde right here. And so there's our aldehyde, right? Which would be the.
Here's the same exact question. Here's the answer to it. So yeah, a lot of these questions are popular and they come up in videos. So here's the same exact question that that was taken from the homework. So study this one. Khan Academy has a pretty good syllabus.
So now in our product,
but what I think I had suggested is that
CL,
because the department had mentioned to me when I arrived that they use the Josh Osborne video series. So that's why I had suggested that you guys go through these videos and watch all of them, because as soon as I met the chairperson and Dr. Gonzalez, this is who they mentioned to me, and they mentioned this video series. So what I would suggest to help your studying now is to go through any of those things that I mentioned with Josh Osborne. I'll try to pull them up. What chapter was that? Chapter 6. So while you're doing these, if you're going to any of the questions, let's say 7.48, and just make sure you go through Fisher projections. This question just asks you to. So this one, when I uploaded when I could say I could answer it fast. In this question, the anti-Parkinson drug droxidopa has a structural formula shown the configurations of C2 and C3 SNR. What I did was I actually just went and found the image for you. So this question just asks you to draw to redraw the molecule with chiral centers. Okay, so let's take a look at this. So all I did was I Googled the molecule to find out which way the OH and the NH2 goes. And look at if you notice, it kind of, this is called, in chemistry, since you moment, it's called a Zwitter ion, meaning the NH3 and the CO2 exchange a hydrogen and go back and forth. So when I could, if you go through them, I tried to add pictures where I could, if it wasn't very time consuming. So take a look at a chirality question. Remember we spoke about So molecule 1 and its mirror image are different. Molecule 1 is chiral. The mirror image is drawn in a perspective having the mirror behind molecule 1, which flips all the chiral centers. Molecule 2 and its mirror image are the same. Therefore, its mirror image is not chiral. This is a little difficult to see, so it'll probably be easier to use a certain test for symmetry for the molecule. Okay, so let's go through your any problems that bring up chirality. Okay, please know this question. This is the kind of question I was looking for. Please know the difference between, please note question 733. So let's take a look, all right? In each of the following pairs of compounds, one is chiral and the other is achiral. Identify each compound as chiral, achiral. So you know Dr. Gonzalez likes these pairing questions. They were on exam 1. So I would focus on this question, 7.33. So here are the answers. Draw the full structure, implicit hydrogens if necessary. Identify the carbon atoms that could be chiral. If the molecule has no chiral centers, it's achiral. If the molecule has at least one chiral center, it is chiral. So the answer to question number 1 is that both molecules are chiral. So Simran, you'd have to know question A, you look at the carbon, the central carbon in A that has both the OH and one has the Cl. And if you know it has 4 different groups attached to that carbon, it's chiral. In 733, both these molecules are chiral. So then you would probably then circle both. Okay. Then you go to question B. In B, both molecules are achiral, meaning you'd have to go to, in the first one, you have to go to the CH. The CH has the BR, it has 2 H's on it. So that rules that out immediately because it has 2 H's on it. Then you have in the one to the right, you have to go to the carbon that has the BR on it. I don't know why that looks. Oh, because immediately firsthand they both have. B looks. I don't know. The one on the right looks. The one on the right looks. I gotta check. So yeah, that was wrong. All right, yeah, I saw that was wrong. So let's look at this problem. This 1-bromobutene has no chiral center. if we look at the carbon, because there are two hydrogens attached to that one. So it's called achiral. But the molecule on the right, that it has, the second carbon has 4 groups attached to it. So it has a chiral center. Okay, so make sure you, Gemini AI doesn't always give me right. I'm glad to go through this a little bit. All right, I got too many tabs open. So hold on. Okay, I'm back. Okay. So I'm just gonna ask now, are there any questions? Any for Johendry, Deepa? Okay, so I'm gonna let you guys go. Today's Wednesday, so the next time we'll see each other. So the next time, so come early at 11:30 a.m. to room E234, and I'll see you then. Good luck. Form, study groups, review the problems, double check Gemini AI makes mistakes. Problems like 7.33 pairs Dr. G likes. And look at the pairing problems, all right? And good luck. I wish you all the best. See you Saturday. Saturday.